There have been countless instruments that have been created throughout history to learn more about space, but nothing has come close to the leaps the world of science has made. With the JWST's cutting-edge technology, scientists will be able to look back in time to when the universe was just 200 million years old. The information we can get from this one invention will pretty much allow us to rewind the clock on the universe. Not only that, but the telescope is able to capture images of some of the very first galaxies ever formed. We're talking about seeing the universe's earliest stars twinkling in the dark void of space. So even on paper, it was more powerful than anything we'd ever seen. It was a Christmas launch for the ages when the James Webb Space Telescope took to the skies on December 25, 2021, riding aboard a European Ariane 5 rocket from the verdant forests of South America. With a budget of more than $10 billion and the collective efforts of thousands of scientists from all over the world spanning 3 decades, this technological marvel was finally on its way. Launches this big come with a massive chance of failure, and it was always on the table with this one too. But things just went as smoothly as they possibly could. After a journey of nearly 1 million miles spanning 30 days, the telescope arrived at its permanent home, Lagrange Point 2. This is a location in space that is both gravitationally stable and opposite to the Sun relative to Earth's orbit. Many other space telescopes, such as the Herschel Space Telescope and the Planck Space Observatory, have also taken up residence here. So it was confirmed that this would be a great vantage point for the James Webb Telescope to get started. As the James Webb Space Telescope began its mission, NASA announced that it would focus on 4 main areas of study. The first objective would be to observe the universe's first light, a key moment in the formation of our universe. The telescope would also study the assembly of galaxies during the early universe, the birth of stars and protoplanetary systems, and planets in general, including the origins of life, all of which are extremely important for the study of space. These are things that have been studied briefly in the past few decades, simply because it's hard to actually get a good look into space to even have a good enough basis of ideas to start off with. So it's been integral to figure out a solution that would allow us to get as many details as we possibly can and then put the brightest minds to work. But before it could begin its astronomical observations, the telescope underwent a series of critical science and calibration tests. One of the most important tests was the deployment of the sun shield. The sun shield is a large, 5-layered membrane that will protect the telescope's sensitive instruments from the sun's heat and light. The universe is constantly expanding, and as things move away from us, their light becomes red-shifted. This means that the wavelengths of light are stretched out, and the light appears redder than it originally was. As objects move further away, they move faster and faster, and the amount of redshift increases. Eventually, the light becomes so red-shifted that it moves into the infrared part of the spectrum, and that's where JWST comes in. Because it can see in infrared, it can detect this extremely red-shifted light from objects that are billions of light-years away. JWST's ability to see so far into the universe means that it can also see back in time. This isn't a figure of speech, it's quite literally how it works. This is because light takes time to travel, and the further away something is, the longer its light takes to reach us. So when JWST looks at a distant galaxy, it's not just seeing what that galaxy looks like now, it's seeing what it looked like billions of years ago when light first began its journey through space. This allows scientists to study the early universe, when the first stars and galaxies were forming, and to learn about the processes that led to the universe we see today. The following day, on July 11, 2022, President Joe Biden, Vice President Kamala Harris, and NASA Administrator Bill Nelson unveiled the first science quality image captured by the JWST. This image, which shows the deepest infrared view of the universe to date, was created using just 12.5 hours of observing time on one of the telescope's 4 instruments. But things didn't just end there. In February 2022, NASA announced that the JWST had captured its first images of starlight. It was a mosaic of 18 scattered bright dots. The image was of a star called HD 84406, and NASA's Associate Administrator for the Science Mission Directorate, Thomas Zurbuchen, said on Twitter that as Webb aligns and focuses, these 18 dots will slowly become a single star. This was an exciting milestone, as it showed the telescope's capabilities and potential for further exploration. In the weeks that followed, Webb continued to make progress. On February 18th, NASA released a new and improved image of HD 84406. The 18 unfocused copies of the star were brought into a deliberate hexagonal formation, giving a better idea of what the final image would look like. Once the observatory had successfully aligned the individual segments of the primary mirror, it began the image stacking process. This brought 18 images on top of each other into one clear view, allowing scientists to see a more detailed image of the star. Webb also took a unique selfie using a specialized camera inside the NIR cam instrument. The camera was designed to be used for engineering and alignment purposes. One of the biggest discoveries the telescope ended up making was looking deeper into the Eagle Nebula. With its massive columns of gas and dust towering into the cosmos, this wonder of space has always been a bit of a spectacle. The Hubble Space Telescope, with its impressive visual capabilities, managed to capture the beauty of these formations, but it could not unveil the secret happening within them. That's where the James Webb Space Telescope comes in. If all of that was impressive, you're not even ready for what happened next. Scientists announced that Webb has successfully observed the oldest galaxies known to humankind. Galaxies that were formed when the universe was just a baby, only 2% of its current age. These 4 galaxies are the most distant ever observed, sitting at a distance of around 13.4 billion light-years away from us. Think about that for a moment. That means that the light from these galaxies took 13.4 billion years to reach our telescopes. It's an almost unimaginable distance, and yet Webb has managed to observe them, capturing images of them as they were over 13 billion years ago. The process of observing these ancient galaxies is no small feat. Scientists first had to identify them, which is no easy task considering that they are so distant. But Webb's infrared capabilities allowed it to pick up on the faintest signals, and as part of the JWST Advanced Deep Extragalactic Survey, researchers were able to identify the 4 galaxies. But identifying them was just the beginning. To truly confirm their age, the team had to analyze the data collected by Webb's near-infrared spectrograph, which allowed them to measure the redshift of these galaxies. Webb could detect it as long as it was limited to a frequency band that is 1,000 times narrower than the starlight. And the possibilities don't end there. Future space telescopes like NASA's proposed Large Ultraviolet Optical Infrared Surveyor will be sensitive to even fainter levels of artificial illumination on the night side of Proxima b. The idea that we could potentially detect city lights on a planet located over 4 light-years away is truly mind-boggling, and a reminder that there is still so much we have yet to discover about the universe. And with telescopes like the JWST telescope, we're one step closer to being in a world where we know everything about what's going on in our solar system and faraway galaxies. And on that note, we'll wrap up today's video. Do you think the James Webb Telescope is the answer to all of science's questions? Or do we need better telescopes? Let us know in the comments below. If you like this video, please give it a thumbs up, and we'll see you in the next one.